Hello, and welcome to this session, Learning Outcome LO1, Understand Mechanics. Today we will learn what makes objects move, stop, or change direction. This session explores the fascinating world of mechanics, a fundamental branch of physics, and examines the principles behind motion and the forces that control it. Motion describes a change in position over time. It involves distance, displacement, speed, velocity, and acceleration. Forces like gravity, friction, and applied force influence motion. Understanding these concepts helps explain how objects move and interact. Mechanics focuses on how forces affect motion. Newton's laws are fundamental to mechanics. The first law, inertia, states objects remain at rest or in straight-line motion unless acted upon. The second law relates force, mass, and acceleration. The third law highlights action and reaction forces. These laws explain diverse motion scenarios. Energy plays a crucial role in motion. Kinetic energy is due to movement, while potential energy is stored. Work involves moving objects with force, and power measures how fast work is done. These concepts explain speed changes and energy transformations in motion. Equilibrium occurs when forces are balanced. Static equilibrium means no movement, while dynamic equilibrium involves constant motion. The center of mass and stability are key factors. These principles are vital in engineering and everyday tasks. Understanding balance helps in various applications. Work is done when a force causes displacement. The formula involves force, displacement, and the angle of application. Kinetic energy depends on mass and velocity. Gravitational potential energy relates to height and mass. Power is the rate of work or energy transfer. In closed systems, total energy remains constant. Energy can transform, like potential to kinetic, but the total does not change. Falling objects illustrate this principle. Initial potential energy converts to kinetic energy. Conservation laws help calculate final speeds and energy states. An object remains at rest or moves uniformly unless acted upon by a net force. Zero resultant force means constant velocity. Any velocity change indicates a net force. This law applies to objects on frictionless tracks. It explains motion consistency in absence of external forces. The second law links force, mass, and acceleration. The formula F equals ma calculates resultant force. Example, a box accelerates with known mass and force. The result shows the force needed for acceleration. This law is crucial for understanding motion dynamics. Every action has an equal and opposite reaction. Forces act on different bodies but are equal in size. Example, pushing a wall results in an equal pushback. This law explains interactions between objects. It emphasizes force pairs in every interaction. Newton's laws and energy principles combine in calculations. Example, a trolley pulled with constant force. Resultant force, acceleration, and work done are calculated. Energy conservation determines final speed. This integration shows practical application of mechanics concepts. Suvat equations describe motion with constant acceleration. Displacement, initial and final velocity, acceleration, and time are key variables. 5 equations apply based on available data. Example, a car accelerating from rest. The equations find acceleration and distance traveled. Moments are the turning effect of forces, calculated as force times perpendicular distance from pivot. Clockwise and anti-clockwise moments balance in rotational equilibrium. The principle of moments finds unknown forces. It is essential for understanding rotational dynamics. A spanner loosens a bolt using a moment. Force applied at right angles creates a turning effect. The moment is force times distance. Example, force applied to a spanner. The calculation shows the turning moment on the bolt. A beam balances with forces on either side. Clockwise and anti-clockwise moments are calculated. Example, a load on one side and a force on the other. Setting moments equal finds the required force. This application demonstrates equilibrium principles. A beam supported at both ends with a load in between. Moments about one end find unknown reactions. Total vertical forces must balance. Calculations show reactions at each support. This demonstrates using moments and force equilibrium together. Explore additional resources to deepen your understanding. Books, journals, and web sources offer valuable insights. Refer to recommended readings for comprehensive learning. Access online materials for broader perspectives. These resources support your study of mechanics. Assignments are due 2 weeks after unit completion. Submit via the provided email. Ensure all requirements are met before submission. Timely submission is crucial for evaluation. Follow guidelines for a successful assignment process. In conclusion, mechanics provides a comprehensive framework for understanding how objects move and interact. From Newton's laws to the principles of energy, these concepts form the foundation of physics. Applying them to real-world scenarios not only reinforces understanding, but also highlights their practical significance in everyday life. If you have any questions, feel free to message us on WhatsApp at 07484361688. Our team will be delighted to help. Thank you, and see you at the next session.